We doing math today. Ain't got time for no games. We doing math today. All work and no play. We doing math today.
During here, going over skills practice 5.11, we are analyzing distributions. In part A, this is my introductory video, and we're actually talking about statistics. So you might ask, frequency, like frequency, how many bottles of water did you drink? This is just simply counting a count. Well, what is a relative frequency? Relative frequency is turning it in from a count divided by the total. So here you have a fraction, and you're basically going to turn this fraction into a decimal. All right, we're eventually going to build a relative frequency histogram. So what is a histogram? It is a touching bar graph, and we're going to make one out of this example here. And then there's two ideas here. There is something called continuous data, versus discrete data. Now, discrete data is using whole numbers. How many people live in your house? Well, that might be like in my house, there is 7 people. That's a whole number. How many cats do you have? That's 3. That is discrete data. But continuous data means you can find numbers in between. Numbers in between. How much data did I use on my phone? 74.5 gigabytes. It's a decimal. You can always find another number between it. How much did that soda cost you? It cost you $2, $1.75. You can always go into smaller fractions. Okay, and then they're going to ask you, based off of your relative frequency histogram, is it normal or not normal? So here in the red, no for stop, these are not normal. These are graphs. You'll notice have little tails. Or you might have something like this. They call this one bimodal because there's kind of 2 bumps. But a normal graph looks like a bell. And you can cut it in half. And we'll learn later on that this is something called a bell-shaped. And it is a symmetrical. You can cut it in half equally. Okay? All right, so they're going to ask you to do this problem. Let's just look at the directions here. Sketch a relative frequency histogram for each distribution of sample data and determine whether it is normal or non-normal distribution. That's why I went over all that vocab. So here, the weights of chicken eggs is my x-axis. And so what you're going to do is you're going to put that over here. Weights of chicken eggs. And this is measured in ounces. And so what you would do is, we call these bins. So 0 to 0.5 to 1, 1.5. And they should be equally spaced. I'm just doing my best. And again, I'm just using these numbers from over here, 2, and then I see 2.4. Okay, so a relative frequency is now we've turned the fraction into a decimal. Now, in this example, I didn't give you the fraction, but let's just say in between here is another tab called frequency. And maybe there's a total of 100 chicken eggs. So 5 out of 100 is 5%, 23. There are 44 eggs, 22, and 6 eggs. And if you add all those up, those should equal 100 eggs. So you take, for example, this one would be 5 over 100 would give you the 5%. This one would be 23 over 100, and so on. Again, I'm making up the number in this problem. They didn't give us a total, but that's how you get the decimal. Okay, so this relative frequency, this area in green right here, is going to go onto the y-axis, which is the vertical. And what I like to see is a maximum. So this is the max, 44. So let's just say you do that at 0.45. And then you kind of just want 9 of those. 1, 2, 3, 4, 5, 6, 7, 8, 9. I guess I messed up, so it's okay, you have an eraser. And then you're counting by 5s. You can count by 10s, it might be too close, but you're going to have to decide what makes it look best. Okay, here's what I'm going to do now. Now I'm going to sketch these. So for this bin, 0 to 0.5 up to 0.05. So that's right here. Okay, so that's the first one. Then I go up to 23. And if you want to, you could draw this line, but I wouldn't recommend it. So like 0.23 is between 20 and 25, so like right here. And basically it's that bin between 0.5 and 1.0. See that? And then go through your dotted, and you can just erase the dots. Let's do that again with the next one, 44, between 1 and 0.5. Right, that's to 1, 1.5. And then you can go and erase these dotted lines if you don't need them. And then 0.22. And then go ahead and erase it. Oh, don't do that. And then the last one, 0.06. Okay. So basically what we did here is we sketched a relative frequency distribution from the table, and then now we need to determine if it's normal or not normal. So I'm looking back over here at the green and the red. Does it look like a straight bump? So what you're going to do here is just take a color and kind of draw over the bars. That looks pretty normal to me because you can kind of just cut it in half, right? So this one I would say is normal. Okay, and that's the introductory for A0. All right, let's go ahead and create one now for A1. So on A1, we said that this is my x-axis. So let's go ahead and draw the x-axis and just draw those numbers. 1.5, 3, 4.5, 6, and 7.5. And this is time studied for math exam. And this is measured in hours. And then the y-axis here in green, I guess in the last problem I should have wrote relative frequency over here. I'm just using the titles. And the largest number I see there is 0.35. So 5, 10, 15, 20, 25, 30. Okay, so then we just go through. I have that 0.20. And then I have one at 0.35. And you'll notice my bin here, 1.5 to 3, which is over there. And again, erase those dotted lines to clean it up. And then 0.25. Erase those lines. And let's do 0.15. Again, this is the numbers between 4.5 and 6, as you can see over here. Trace the dotted lines. And then the last one, which is 0.05. Trace this line. And then we're going to take another color and just go over it. And what does my data look like? Okay, that looks like the one here over here in red on the left side. That would be called as skewed right because the tail is to the right. So this one is non-normal. All right, let's go ahead and go over now to example number 1b. Do the same thing. I have the x-axis over here. So this is math, exam, test scores. And I have starting at 50, 60, 70, 80, 90, and 100. Equally spaced. This is the y-axis, so I'm going to call this one relative frequency. And the highest number I see there is 42. So maybe like 0.45. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that would be counting by fives. You could do like something like this to save yourself some time. And then you know the tick mark in between is just like a 10. Alright, so let's do 0.10. There's 0.10 on the relative frequency. 0.22, so that one is 0.20, so something above it. Right there. .42, so that's 0.40, so above it. Which means the bar is as high as 0.42, 0.18. I forgot to. And you can kind of see my bar here is not the same size as the other ones. So I didn't do a great job there. And the last one, 0.08. And then just pick your favorite color and go over the now this one's not going to be exact, but it's kind of like putting a blanket over all these buildings, and this one looks normal. Right, you can almost cut it in half. Half the pie to the left, half the pie to the right. Awesome. Let's go on to A3 now. Alright, A3 here. I got men's height. Measured in inches. And I have 60, 65, 70, we're trying to do our best to equally space, 75, 80, and 85. That's our x-axis, and our y-axis we're going to have relative frequency. So we have to make these titles here, and then the biggest number I see here is 0.67, so maybe like 0.70, and I'll just count by tens. 10, 20, 30, 40, 50, 60. go through these. So 0.03, something really low, like right here. And 0.14. You can go back and erase all of them later. 0.67. Uh, 0.15. And 0.01. But just something like you could barely see it, right? Let's go back and clean this up. Okay. What does our graph look like? I think it looks normal. Why do I think this problem looks normal? It's bell-shaped. And you can cut it in half, right? Symmetrical. All right, A4 here, we're going to make a relative frequency. Remember, they've done the hard work of creating decimals for us. This is just seasonal rainfall measured in inches. And then I'm going to use those numbers. 0, 6.0, equally spaced 12.0. Looks like they're counting by sixes here, 18, 24, 30, and 36. Okay, so that was on the x-axis. On the y-axis here, we're going to do relative frequency. Relative, that's an R, frequency. And then locate the largest number here, so 0.39, so it's like 0.4. And you can just break that up, right? 0.4 and half is 0.20. Half of 0.20 and 0 is 0.10. That's 0.30, and if you wanted to, you can put other indicators in between those. Okay, so let's just graph those. That's like 0.025. So it's like 2.5%. So less than 5. So somewhere around here. See, the height goes to that number, about 2%. Okay, the next one's a big one, 24%. So that would be like right here. And I'm using those dotted lines as reference to figure out how high that is. .391. Okay, and then the next one, 15. Gets confusing anytime, you can just go back and erase those lines. But those dotted lines super helpful. What's the next one? 10. And then the last one is about 7. Remember, these are histograms, so the bars must be touching. And then you just take your favorite color. I'll use this problem red here. And how about number 4? I would say this is non-normal. Because if you cut this in the middle, that does not look symmetrical because not bell-shaped and not symmetrical to cut it in half. Okay, and that was A4. All right, let's go ahead and try now A5. Male life expectancy is on the x-axis, the horizontal, so I'm going to write that title down there. Male life, how long we expect males to live, which is measured in the units, years. And so I have 36, 46, looks like they're just counting by tens. And then I'm going to do on this here green, the y-axis, which is relative frequency. And again, locate the highest number, which would be 0.50. And just cut, you can just maybe count by 5s, or 10, sorry, 10, 20, 30, 40. And then the first one, 0.15, 0.10, 0.15, 0.50, and then 0.10. Let's go back, clean those up. Okay, then take your favorite color and kind of try to sketch what's happening here. Remember, just pretending like they're buildings, or you're building a couch fortress, putting a blanket over it. What does that one look like? Is it symmetrical? No. Does it look like a bell curve? No. That means it is non-normal. Whoops, that's a no. Okay, spell mistering, non-normal. Okay. All right, A6 here, we're asked to create a relative frequency histogram. Here I have the x-axis, and I'm actually just going to use this line right there. So let's write down what that is. Commute time in minutes. Ask your parents how far they travel. So how long it takes them in the car. So evenly spaced, I'm counting by 15s here. And then, of course, on the relative frequency, this is the y-axis. Pick the largest number, and then round up from there. So that'd be like 0.40. Half of 0.40 is 20. Half of 20 is 10. So I'm counting by tens. 10, 20, 30. And if you need some references, you can put ones in between. And I did not label it. Relative frequency. We kind of need to know what that means. And I have 7%. So that's above 10. I mean above 5, right? That's 5. 0.27. You can always use these dotted lines for references and just kind of build it in there. 0.38. My ugly looking building. Can always go back and thicken it in art. 0.25. And 0.03. See, straight building now. And then go back and put a bed sheet over the buildings. And what does it look like? Does it look symmetrical? I think so. Which means just cutting it in half, right, like a mirror. And does it look like a bell curve? I think so. So this one is normal. It looks like a normal distribution graph. That is A6.
We doing math today. Ain't got time for no games. We doing math today. All work and no play. We doing math today.